In this session, we are going to study the most fundamental execution system called in Linux, called as execve. So, execve. This is like if we have to talk about, let me tell you one thing. Every time you run a program in Linux, kernel executes it using execve function or a system call. So whenever we type, say for example, say let us say /a.out. So if I type say /a.out, so internally it results in an execve system call. Like one can check this. So if I write say strace this, then you should see at the top you can check this, correct, execve. So let us understand this clearly, and then again we'll come back to stress. Right? So man execve. So this execve is a system call that replaces current process image with the new program. So it does not create a new process. Please understand this. It is similar to what we saw earlier as well. But here, like for exec function call that we talked about, like execl, execv, execvp, or execp, and so on. So like we used to specifically write path and then arguments as well separately, and then we used to always end with null. Even with respect to like execcle, we saw like how exactly environment parameters are to be added. So it is having the similar kind of parameters. Only thing, like there are only three three parameters for execve. So what it does, it removes old code, it removes old data, it removes old stack, it removes old heap, and loads a new executable into the same process. Let us keep in mind that process ID will remain same. So as I stated, these three parameters are okay for this function. First is like path name, which can be full path or relative path of executable, then argument array, and then environment array. Both arrays must end with null. This is important. Okay. One more thing, execve does not search path. We have to explicitly add the exact path. So let us try working with this. Say for example, with a simple code. So let us say if I write I will just write a very small code to really understand what exactly is happening. In the main, let us write printf and then return 0. Let us compile this code. So our code got compiled and it created a.out. Suppose if I write /a.out, what it will do? It will print hello from, like what are the message that we added there, hello from a.out. Now important question here is, how did this execute? So what happens when we type /a.out explicitly? So let us understand this step by step. What happens? The shell is reading your command. The shell calls fork. That means like process would be child process would be created. Then the child process calls execve with /a.out and argv and envp. Like for example, if I go back to this code and if I simply write say get char, just to stop it for a while, and we can check this output perspective. So when we compile the code and when we execute the code, and if I go and check ps-ejh, you will see that this a.out is created. So what happened? Shell read our command, like we wrote ./a.out there, like in the other terminal, correct? It called a system call fork. Then when the child process was created like this, the child process is calling execve ./a.out, argv and envp. So one can check this, like for example, if I write here strace ./a.out, one can check it here above, correct? Because it is not having other parameters, ultimately they are passed as null. So list is passed. Now the kernel loads this executable. When it sees this execve, the kernel loads the executable, control gets transferred to a.out, and that's why you can see this output is here, hello from a.out. So ./a.out works on the shell because the shell is calling execve with the relative path, and the relative path was added there, like one can see here, it added the relative path. Now question is, why do we write // for our executable? Like you must have seen here, why we write this // because the current directory is not usually as a part of path. So execve does not search for path. That's why the shell needs an explicit path, and that's why we write ./a.out. Correct. Now here, right, like when we are giving the shell this command, actually we are providing the exact location, because the shell passes ./a.out as a parameter to execve. Correct. Now there definitely would be a question, then why our ls doesn't require it? Because ls, when it gets executed, when I write, say for example, this ls, okay, if we go up and see for ls, you can see that it is executing it with the complete path, then the parameter, correct, which actually was written with ./a.out, because this is our executable path. And in, like when I tried checking with say strace my a.out on the other terminal, you can see that here this is path of my executable, this is argument array, correct. Third parameter would be like this environment parameter, so it says 45 variables are taken. And if you see, like for example, if I write print env and we write wc-l, you will see this 45, and that's why that 45 number was added there as a parameter there, 45 variables, correct. And it returns 0, that means 0 means success, and this is what your strace output is. This confirms that the kernel executed our program with execve. Fine. Now, like if at all, say for example, if I have to strace a shell like ls, so like what we did was we tried the same thing with ls here, strace ls. And this is complete ls program which got executed here. So if I go slowly up, you should see this. Right? So when we typed ls, execve shows /bin/ls or /usr/bin/ls. The shell searched path and found say /usr/bin and then called execve. Again, execve is the final execution step. So let us do this again with respect to like, let us make use of this execve call. How to use this? So let me write emacs execve dot c, and we will use it with fork because now we already have seen other things. So let us include stdio.h hash include unistd.h. Correct. Then we have to include, because we are going to make use of fork, so that's why sys slash types.h. Correct. Then integer main curly bracket pid underscore t variable equal to pid, and then we are going to give call to fork function. So if pid is equal to 0, then so in because we have to call execve, and we saw that there are parameters, argument, the executable name, arguments, and environment. So we will define char star args. Let us give args. You will provide like this, and then you should end it with null. This is args. Then char star env. Okay. Then suppose we don't want to give any arguments, you should write this. Correct. Now you give call to execve. So we have to write here slash bin slash ls, and then just pass the arguments args and then env as a third parameter. Fine. Now suppose it doesn't get executed, then p error execve failed. Else printf parent process continued. Fine. So this is our code, and then just complete this. Write return 0. Our code completed. Now let us compile this code. gcc execve.c execute this. So we got output. One can see earlier our code would be there. Correct. So parent process continued. Correct. And then we saw this message, like this is the file that we had, the different files that we had there. Correct. Because it was a character, I gave one shell. We fire it strace for my a.out. Now let us go with this strace call. Now let us see this execve. So when it executed, actually what it did, it executed a fork system call. Process was created. Correct. Now to get more help, let us add there, say, get char, so that we can stop it and check whether the child got created or not. Printf I am in child slash char. So like when it is executing this get char, I am also adding get char here. So when parent continues, parent completes, then get char is after that printf, and here we will write this get char after the child. Correct. We will try to see like what happens. Fine. Let us save this code. Let us execute. So I am going to make use of other terminal as well now to show you this. So if I go to other terminal and check for ps dash ejh, you should see a.out. So because of fork. Now what will happen ultimately, like I am in child, it is showing this. So I said 3. If I go back, 11154 and 11155. So you should see 11155 is here, a.out. Now a.out would be executing after that character ls command. Now you will see like that child got terminated, a.out was gone. Correct? Now here it is for the shell bash. It is bash output. So what happened here? When we type a command, shell parses the input, shell call fork, child calls execve, kernel loads executable and program. So final step of execution is always execve. Correct. So let us understand here some summarized points. Execve is the real execution system call. It replaces current process image. It requires explicit path which we provided in the code. Correct. Way that we see here. Right, so let us say we print this below, then we can check for it. So it requires explicit path, correct? Then arguments requires argument array ending with null, which we added there, as well as environment. If at all you want to add, it does not consider search path, like which was provided by environment variable path, and it is visible using a strace. Correct. Now let us do execute this again, and let us see like if we can control something this way. So if I go and check this, you can see the image, child image got replaced with ls, and because ls command completed, it is showing us defunct. Correct. So every command that you run in Linux eventually goes through execve. So let us conclude this by saying the shell is just a manager. The real executor is execve. And using a strace, we can definitely watch how the kernel performs the execution live.